Okay, so let's open SQL Developer. This is not good. Why is showing me this screen should be in here? It's too big. Okay. All right, now let's log into equals. Something's not right. Something's not right with this app. Huh. No. Something's not right. I think it's crashed. Oh, let's see. Oh, I see. What happened there? So this is already opened. But then I try to open again and then give me this. So what I would do, cannot close. So let me see if I close, exit this one, the whole thing, commit changes. Yes, let's put 24. Give a name here, today is 11. Okay. Now let me see whether that can help me to come back. Sorry for this. This application need to be closed. Let me try to do task manager applications. Okay. Now let's do it again. All right, so it's coming back. Okay, log in. All right, so we said there are two different ways to copy data. Approach one is just use create table command. So for example, if I need to get all managers information to create a new manager table, so we just say create table managers as, and then we'll just say select. So let's say select EMP number, ename, maybe hire date, and also DPT number from EMP, and then say where job is equal to manager, something like that. So this is just create a new table. So this table can be, say, currently I'm using inside here, inside the same account. Of course, generally, you're going to have like a database link at another place, right? So for example, if you have database link called Japan, JP, then the table will be created in that database, not in your current account. Okay, but of course you have to have a database link JP first. Okay, and the second approach is using insert. Okay, insert into. Okay, so let's just say if I do I have a temp table? Let me say let's create a temp table. Create table, temp table. Okay, so the temp table is going to have 2 columns, maybe number column. Let's just say that is number 4, okay? And then let's say char column, that is a char, or let's just say that is 45. Okay, so those are only 2 columns for the temp table. And then create, I misspelled create. Okay, so let's run that. Then table is created. Now let's say I want to insert. Okay, insert into temp table. Okay. And then instead of using values, this time I'm going to just use select statement to get the values, and then those values will be inserted into this table. So select, let's just say I want to insert get employee number and the ename from emp, and then where job equals to, let's say, salesman. Like that. Okay, so this is, again, this temp table does not have to be inside your account. You can just say, you can do that for another, the data is, the table is in another place. Just add and say Japan, okay? Use database link too. Okay, so this is assuming that you already have a backup table. The table structure is already there, and you just need to get data and then put data into that. Okay, so that's insert. When you do insert into, just make sure that there's no as. Okay, like a create table. In the create table case, use as. The second thing you need to notice that this select statement generally will give you multiple rows, right? But if you use insert into and the values will be just 1 row at a time. Okay. So value, a bunch of values, and then if you insert the second row, then you have to do this, do the statement again. So it's insert into that, and then values, second row, third row. It's a repeat that. But this one will give you insert everything in one shot. So let me just get rid of that and then run it. It should be fine. Okay, so 11 rows are created. So now you can just check the table is a temp table. So the data should be in there, okay? All right, so all the salesman's information has been added to that table. All right, so does that answer your question? Okay, Yanni?
Yes, it's clear. Thank you.
Okay. All right, does anybody else have questions? So last time we stopped at the decoding function. So let me check what other things we did not do. Let me see. Okay, so these are the things we did last time. Copying data, and then we did functions, expressions. So we already know how to do sysdate, right? MVL, right? So by the way, MVL is, you can use decode to do MVL too, right? You understand? And upper, we know that. Lower, today, to decode. And we did soundex, did we? Did we do soundex? Like, so use sound of a column value equals the sound of something else. So for example, if I'm going to say, find somebody who has a name like something, let's say select ename from emp where sound x of ename equals to sound x. So let's just try to make some kind of name here. Let's just say give us some kind of name. James Black, B-L-A-C-K, okay, Black. Now let's see, what do we find? Oh, Blake, okay. So in this case, you are comparing the value of that each column, the sound, the column value, sound, the e-name column, comparing for each employee, you compare the e-name column sound, whether the sound is same as this sound, the sound you're comparing to. Okay, so that was sound function, sound X. So what we did not do is the contents. So that contents actually will be used for text search. So what we do is we will we'll have to go to equals first. Okay, let me show you how to do that. So I'm going to use you can see sample database from help desk for text search. So you go to public, then you go to script loader again. Okay, so now let me see which place you are looking at. So let's see, help desk right here. Is very beginning. So you see that create a help desk database. Let's do that. Select that, and all the way to the place to the before creating publisher database. So every lines of code before that, you copy, okay, and then you can paste into your SQL developer and run it. So I'm going to select all of them. Select all of them, okay, and then run. So it should have no error messages generated, and if you do, just run it again. Should be fine. Okay, I'll give you 1 minute to finish. Are you ready?
Yes.
Okay, good. So now I can delete this one. Delete this, the one I do not need. Okay, right. Okay, so we don't need that one. Okay. Okay, so first thing I want to do is say basically we are going to do text search. So now just imagine that. Let's describe the columns. Okay, describe responses. Okay, so here you have response ID and then text, and this text is generally is pretty large column. Is vocab 2 in this case, and also have like create some other columns like a date. Okay, which time was created and created by whom, modified by whom, so on and so forth. And if we look at another table called request, should be similar nature. Okay, so basically this task has a request ID and a text. So each request ID request. So basically you can just imagine that request is some kind of like a short article. Okay, the article will be stored in this column. Okay, and of course there's only 800 characters, but generally this text column can have like can have several megabytes or even gigabytes of data, like a whole book to be stored in the column. Okay, so what we want to do is we want to sort this column to see whether the column contains certain text. Okay, so you can just imagine that that's a very common job for like a browser, web browser, like a web browser, like a Google, search engine, right? So basically, they they use like a robot, go to every website and trying to get those like word keywords for inside those website column, inside those website. And then we saw somebody trying to search for something, then they will use that, use those keywords to try to find which website would be matching, right? So again, if you have a lot of email, then this will be also useful, right? So just imagine that you put like an entire email in this column, and then you try to search for email where say whether the email contains certain words. All right. So this kind of job is pretty. You can just imagine that it is very time consuming. So essentially, to search, say whether an article or book contains a certain word, and the searching has to go through pretty much like from the beginning to the end, every word to see whether the word is matching the word you're looking for. Okay, so you can just imagine that is very, very time consuming. Okay, and just imagine that if you go to library to start trying to find a book. Okay, if a library does not provide you index, then you basically have to do the same thing. You have to go to search for every bookshelf and every book in the shelf, and then start from beginning all the way to the end. So if a library has like 6 million books, then you have to go through every book of the 600 million, every of the 600 million books, right? So that is very time consuming. So apparently that is not a good way to search for something, search for a word or search for a book. So we do need an index. Okay. So generally, when you create a database, when you have a database, then Oracle will automatically create index for your primary key and the foreign key values. And those indexes will be just index of the entire columns. So for example, if you have a ename column, say suppose you want to index that column, then every employee name will be indexed. So for example, employee name is John Doe, then the entire name will be indexed. Okay, and again, if you want to index this, like create index for the text column. So remember that this text column here, and this text column is going to have many words, right? So if you index that text column, then just basically entire column value will be indexed, but that's not useful for us. That kind of index is not useful. Okay, what we want is we want to index every word inside the index, inside the column. Does it make sense? So we need to create a special kind of index. Okay, so let me just tell you how to create index in general. So let's say create general index. Okay, so this is command to do that. Just say create index. Okay, and then you give a name for the index. Suppose I want to create an index for employee name of the employee table. So this is what we do. We just say ename index. Just say something like that. Okay, ename index. All right, and then you specify, say on which table, on EMP table, and then which column, and say ename column. Okay, so that is how to create general index. So if you want to have a certain column to be used very frequently in your searching, and the Oracle database does not index that automatically. If it's not a foreign key, primary key probably will not be indexed. And then you want to make sure that that is indexed, so that you want to improve your search query efficiency. Then you can just create index like that. Okay, but in our case, we need to create a more special index, and that index is more like a so-called context index. So we actually index every word inside the column. So for example, if you're searching, so if employee name has first name, last name, and middle name, then that basically that kind of index will index first name, last name separately. Does it make sense? Okay, so let's say how can we create that index? Okay, so we'll say create index, same column, same first part will be same. Okay, and then let's just say I want to create the index for request text. So request text. Okay, request text index index. Okay, so give a name, and then on which column? Request the name of table. and then name of column, which is text. Okay, so that would be just creating general index if you stop here, but we want to make the index to be special kind of index. So to do that, I will say index type, okay, is ctx sys ctx context system dot context. Okay, so then you have after specifying that, the index will be created for every word inside the column, text column. Okay, and then there's one more thing that we need to handle. So this index job is typically very time consuming. You know, if you have if you have a column has a lot of articles, a lot of papers or books, then index is going to be very slow, right? So you really want to make sure that this index will be incrementally updated. So if, for example, every time we change the column value, then the index should be changed. So for example, if you go to the article and then change a few words and then delete a few words, and then the index should be your index should be updated accordingly, right? And you do not want to do that. Wait until everything's finished and then end of the day you do that. And you could do that. But that may not be what you want. So usually people what they do is they will write some kind of like a PLSQL trigger, like some kind of program which will monitor the changes, and then the change whenever you make changes to your article, and then the index will be automatically updated right away, instantaneously. Okay, and so that kind of trigger can be, if you use Oracle 10 and later, that trigger is no longer necessary. And what you need to do, however, instead is you need to specify that the index will be synchronized. To do that, you will say parameters, specify parameters. Then the parameter is simply just put it inside a single quote. Okay. And just one parameter. The parameter just make sure that is sync. So let me put that back. Okay, so inside single quote, and then the parameter is sync on sync parentheses on commit. Commit, right? Commit means saving. So if data has been saved, then you do basically this parameter will direct that index to be synced. Okay, so sync, and then inside the parentheses, say commit, and put everything inside a single quote. Okay, so now this is, so this index will be indexed in every word, and the index will be updated, every time. For example, if you delete article or change article, change the text column, then the index will be updated automatically for you. Okay. So you do not have to write a separate code to do that, to monitor the change and then update the index. Okay, now let's run that, and it should be fine without error. Let me see. It does take a little bit, okay, because it's doing the index, okay? But if you have a lot of text, then this will take a longer time, okay? All right, so this is for request text index. Now let's do the same thing for response index. So remember, in response also have a column called response, also have text column. So this helpdesk database is set up, just have two tables. One table store all requests. For example, end users have some kind of problems or requests, and they will submit the request to the helpdesk, right? And then the helpdesk, then the technician is going to provide a solution, and then they will respond to those requests. So responses will be inside this text column. So I will do that same thing. I'm going to index that too. So create the index, okay, and then say response index, response text index. So just index, okay, and then on responses, and then text, okay, and then index type is ctx sys dot context, okay, and then do the same thing, parameters, and just understand that just provide essentially just provide one parameter here, sync and then on commit. There we go. Okay, let's run that, and they should have no problem. Okay, so this index is created. So every time you say a little bit, just a few seconds slow, but that just means that it's doing index. It's creating index for every word inside those two columns. Okay. All right, let me see whether anybody has questions at this point. Is it working fine, right, everyone?
Yes.
Okay, good. All right, now with the index, then we can do so-called text searching. So basically, we use a function called contains. Let me just tell you what contains does. Okay, let me just do that whiteboard here. Okay, let's create a new one here. Okay, so this contains function. Okay, take two parameters. The first parameter is some kind of text. Okay, so text. And then second column is basically just some kind of words. And these words can be connected. These words can be connected by using like connectives like and. So if you're searching for multiple words, and if you want to make sure this text contains this word and this word, or you can also do or. That will allow you to search for, say, the text contains either this one or that one, either this word or that word, okay? And then, or you can also use so-called near. So that in that case, you're searching for the words that are nearby each other. So for example, you want to search for like a text which contains software and near engineering, okay? Or and engineering or all engineering. So basically you are using this connectives for the words, okay? And then this function will evaluate, will go to text and search for those words. And if they found a matching, then it will return a value greater than 0. We return a value, okay? If no matching, then this will be 0 or negative. Make sense? So if there's any matching value, say this word, for example, you search for software, the text has software, then you will return greater than 0. Okay, so that's how this function is working. So let's try to do a few simple examples first. Okay, first, let's say I want to find the responses. Let me copy this. Okay. So let's say I want to find the responses that contains word Unix or VC++. Okay, so we'll do select maybe text. Okay, from responses. Then say where contains. So we want to make sure the text column contains two words, which are respectively Unix or hold on. We need to put everything inside a single quote. Okay, Unix or VC++, single quote. Okay. So we are searching for two words. See whether any responses contains either one. And there we go. So that's how we do that. So basically so even though it's multiple words, but connected by or and or near, but then you have to put everything inside a single quote. Okay, let's run that, and then we should get also. So we have found three texts, three responses contains that. So VC++, and what about this one? This is Unix. Right? Okay, so now let's do next one. Let's say this time I will find the responses that contains both Words, Unix, and Windows. So same thing, select text from responses, then responses. I think this is spelled responses. Yeah. And where contains, and then we're trying to sort the text column contains Unix and Windows. So both words. Okay, greater than 0. Okay. So by the way, if you have more than 2 words, then you can use and or to connect them. So you can say and or, and also you can use parentheses to surround things. Should be evaluated first. And so basically, you can expand that and or, pretty flexibly to get more words to be sourced. Okay, and then let's run that. So we found one record which is matching that. Okay, and then next, let's say I want to find find the responses. So let me see why this is. Oh, this is okay. So this okay. This is an example to show that. Okay. So basically 3 words. So this time I will find the responses contains both words Unix and Windows, Unix and Windows or VC++. So what does that mean here? So I think it contains both these words or contains VC++. I think, right? So that it should be, let's interpret that way. Okay, so contains both these words or this one. Okay, so let's write that logic here. Select text, or we can just have ID also. ID text from responses. Is responses? Yeah. Responses. Where contains. So we also check text column. So now let's say, well, how do we do that? So first of all is Visual C++. Okay. Or then we have to have those both words together, right? Both words. So I put parentheses here, Unix and Windows. Something like that. Okay, parentheses. Okay, so you are searching for either this word or both of these words. Okay. Make sense? Okay. There we go. So we'll find this one, which does not have Windows or Unix, which just have a VC++. And this one has Unix and Windows. And this one does not have Windows or Unix. Okay, so 3 records are retrieved. So what if inside the text, inside what you're searching, has a word or and? What if you have those situations? Well, if that is the case, make sure put the words inside, put the word or and inside the curly brackets. So let me see whether I have an example for that. Okay, I don't have an example for that actually. So let me just do that. Okay, just say I search for trying to find one. Okay, find the request that contains word end. Okay, word end. Okay, so select text from request will contains, so text column, then single quote. Okay, inside a single quote, you're supposed to put end here, right? But this end will be interpreted as connectives, so we have to put that inside curly brackets. Okay, the same thing with all. And then we are going to search for the word end only. Make sense? Okay, now let's run that. Does not have anyone. That's interesting. Oh, let's see. Let me see. Select text from request. Okay. Let me see whether we have any. I don't think there's. Indeed, there's no end. Do you see any word end? Okay, there's no end. What about response request responses? Responses does not have end too. But there's end here. So let's search for that. Search for responses. And let's see. Still no result. I think this time should be was and or use and or. What's going on here? Let me see. I thought that was and or. That is correct one. Parentheses. Okay. Did I miss that? Let's see. Still not getting a result. So something's wrong here. Should use single quote, right? Otherwise this will be wrong. So have to be that. Then let me see what if I don't use single quote. Just try. It may not. It will be incorrect, but let's give you arrow as. So basically, this end will be interpreted as. Let me see. Yeah, and will be interpreted as connectives. But then I put this. It's still not working. Why? And Windows. Let me see. Single quote around that. So this time find something. Let me see whether is this end here. Windows. This one has end and Windows. I see. So searching for single word end will not be working, but if you have multiple words, then that should be okay. Okay, that's interesting. All right, so basically, if you have all end, if you want to search for those end or all, just put them inside, and then you also near. put it inside the curly brackets as the search word. Okay, so that is a way to solve that problem of confusion and all. Now let's try to use example for near. Okay. Okay. And let's say responses in which words Unix is close to Windows. So that will be very useful if you have a large, like a book or a large paper, large article, and there are a lot of words, and they're trying to search for words. Not only contains those words, but also they are close to each other. Okay. So in our case, we probably do not, because our text is pretty small. It may not make much sense, but and it's just trying to show how does that work. Responses, and then say contents, okay, and text column, and then this time let's just say I want to search for Unix near, okay, and then Windows, okay. Okay, if you're searching for word near, if near is the word you're searching, then you have to put that inside the curly brackets too. Okay. All right, now let's see. And then yeah, Windows, Unix, they are, this text is very small, so it does not make us if you have large text, then this will show up the difference, All right, and now what if we for some words we don't know how to spell exactly, or there are some words may have different stems. So for example, when we're searching for a word like a walk may be presented in the text as walks or walked or walking or walked. So they have different stems, right? So how do you handle those situations? Okay, so let's just try to do some of that. Okay, so let's say how do you sort? So let's try to do stem search. So search for words that share the same stem, like walk, walks, walking, walked. Okay, so let's use example to demonstrate that. So first, let's say I want to find the responses that contains word support. Okay. So select text, and then from responses, contains. So we see text column contains support. So now the support, we're not just looking exactly the word support. Not just that. If you do that, then you probably will find something. But we want to also looking for the other word that's just a variation of that, like supports or supporting or supported. So in other words, they all have the same, come from the same stem. So in that case, you would just put a $sign in front of that, $sign in front of the word. Okay. Does that make sense? Of course, you can have other words, so and something else, and then you can also use stem search. So for example, say walk, okay, walk. So in that case, you're searching for the text that contains support or walk, or there are variations. There are different variations, okay. So as long as, for example, this one may be walking and this one may be supported. And as long as they have those, then they will be retrieved. Does it make sense? So let's just choose one. I think we probably do not have both. Let's try the one here. Okay, so now let's see. Supported here. What is this one? This is also supported. Okay, so again, so this is a stem search. Okay, pretty simple, right? Easy, pretty easy. Now, what if sometimes I may not spell word correctly? So that would be something called like a fuzzy search. Fuzzy search. So let's do that. So that is very common in Google, right? So you're searching for a word and then you misspelled, and then Google will come back, tells, do you mean this or that, right? So that is actually fuzzy search. So let's just use example for that, okay? So let's say I want to search for responses that contains word variable. So you know that there's a variable is misspelled, right? Okay. So how do you handle misspelled possibility of misspelled word? In other words, so select text from responses, and then where contains. So I'm searching for text column, and then the word I want to search is a variable, something like that. Okay. So if you're just trying to search exactly matching, then you probably cannot find anything because there's no text which has that word. However, say this word, I'm not sure, right? I'm not sure. So I will just put a question mark in front of it. Question mark. Okay, so that's a fuzzy search, fuzzy match. There's a question mark in front of the fuzzy word. Of course, you can also connect some other words, right? So for example, I want to search that and say stem search. Okay, so let's say $sign and then support. Okay, you can do that too. I don't know whether we can find that, but or maybe just use all. Okay, all. I think that we will be able to find that. So here for this word, I'm not sure I spelled correctly, and for this word, for support, I want to search for all variations of that. Okay, they have the same stem, so this all. Okay, so let's try that. Oh, by the way, this will not be matching this one. So I will run this and then we'll get rid of that other part. Something's not correct. So what's wrong? Table view does not exist. Let me see. I misspelled a table. Responses. Okay. So you found the one which has a Unix or variable here. Variable. Oh, the support is misspelled. Support is misspelled. Let's just do question mark here. Okay, so now you do supported, and also variable both. Okay, and then to match this this question, I'm going to get rid of this part. You know that we are talking about individual word only. Okay, so if the word that the misspelling may not be right or not sure, just put a question mark into it, so the Oracle will search for all possible matching that just similar look like that. Okay. All right, now we can also search for words based on the sound. So this is just to make sure you understand the difference between this and the sound search and then the sound X. When you use sound X, you compare the entire column value with a sound of one word or several words. But here you are comparing the sound of each individual word inside the column to the word you're looking for. Okay. So let me give you, let's see, search for the words. Okay, search for words sounds like some other words. Okay, so let's use example here. Okay, now we are finding the responses which contains words sounds like Unix. Sounds like Unix. So actually, let's try to. I think there's a word called Unix. Let's just do this one. Unix. Something like that. Okay, Unix. So that will make a make the question more meaningful. So let's say select text from responses, then where, then this time you also use contains, and then search for text column, and for the word you're searching for is Unix, okay? And of course, you search like this, it will not give you any result. However, I want to search for word that has sound like this, sound like that. So for the sound, in that case, say I want this word to be searched by sound, and what I will do is I will just put a question, put an exclamation mark in front of it. Exclamation mark. Okay. And of course, you can also search for some other things and something else, right? And say what support or fuzzy search, something fuzzy search like variable, something like that. Okay, variable, something like that. So you can also so basically and or connectives, and this exclamation mark is for individual word sound, and then the question mark is for individual possible misspellings. Okay, and then dollar sign is for like a stem. So you can use for each word that you're not sure, then you can use one of those sound, question mark, or dollar sign. Okay, so here let's just try to say that it's the sound only. Okay, Unix. So now let's see what do we find. And I have some problem here. Let's see, SQL comment not probably ended. Why? Why responses? Okay, responses have a single quote. Okay, so we found that the variable are different for Unix and Windows. So Unix, okay, matching the sound. Okay. And so remember, let's compare that with SoundX. Okay, let's say select, say for example, ename, and job from emp, and where the job SoundX of job title is equal to SoundX of say salesman, something like that. Or let's just do clock. Okay, so I think they should imagine clock. Okay, so here let's run that. It will give you anybody, nobody. Job is not clock. Salesman. See. Still no, salesman. Okay, so have to, yeah, salesman, like that. So you look at here, this is actually looking for entire columns sound. Entire columns, you know, like a salesman, entire column sound equals the sound of the one you are trying to match. Okay, but here you're looking for the entire text. You're not using sound of entire text column. Instead, you're using sound of individual words inside the text and say whether sound is matching this. Okay, does it make sense? So this is what we did not finish in the last class about the text search. Okay, it's using contains functions. And let me say whether you have any questions. So basically, it's not. You don't think this is easy. When you create, it's a very creative job to create some kind of search engine that can search a variety of just response to a variety of different accommodate different requests from users. Okay, so it's sometimes that why Google is so popular, so powerful, so successful. It's just because they are search engine, right? So just imagine that if you know how to manage those grasp those basic skills, and then come up with some kind of creative solutions to search for something that the user really retrieve the user the best match. Okay, and and then then your solution will be very, very, very useful. So I am going to move on. So unless you have any questions. Does anybody have questions? So let me log on to eCourse and then look at this week's outline. Okay, so that would be week 10 outline. Okay, so text search, we already did that. So that's lecture note number 1. So we finished that. Okay, so now let's do lecture 2. So lecture 2, we are going to do so-called rundown search and the rank search. So for example, I don't know what would be a meaningful context for rundown search. Rank search is very useful. So you want to search for, say, for example, employees by, so like a first, top 3 salary owners, or maybe you want to rank those employees by their rank in terms of their certain kind of performance, right? So you want to use SQL to generate the rank. Okay, rundown search. The only thing I can think of would be, say, if you want to give like some kind of word randomly every month, so select one employee to give the employee some kind of like a bonus or whatever. Okay, that may be meaningful. I'm not sure it's meaningful in the business context, but in some other context would be meaningful. For example, say I have a large number of questions in my question library. I want to randomly generate one question per day when you go to my website, and every day you say different question, something like that. So that will be rundown search, right? So get one question randomly from my question library. Okay, so that would be one meaningful context. Another meaningful context would be those in those settings in like Las Vegas, right? So generating some kind of rundown result from a database, generating some kind of rundown records, and then see whether gambler is lucky or not to get it right. So there's some meaningful context. Okay, so for both of them, I will cover in one place. It's just because they are very similar. Okay, so let me just put this title first here. Okay, so rundown search and the rank search. Okay, so first, we need to understand that when we let me do this. So let's say select star from EMP, run that. So here I basically just get all the just present the data from the EMP table without any like selecting cases or dividing cases or even ranking. Or no, there's nothing to be just original order, original whatever data in the original order will be presented. Okay, so now if you look at this table, this table here, the result. Okay, so it has multiple columns, right? Those columns will be in the original order that you create the tables, and also the data 1, 2, 3. All those will be like in their original order. We insert new data. So, for example, say at this point I have like 40 employees, right? So if you insert another employee, that employee will has a row number like 15, and then you insert another one that will be 16. So this order has not been has not been changed. It's just in their original order. Right. So in this case, you see that there's like you don't see that this is not a column. Okay, the first one, but they have like an index here. They have like a row number here. This is for row 1, row 2, row 3, like that. And so that is actually something available to both tables and also SQL statements. So we select SQL, we create SQL statement, like select something, and then all the records will have like a row number here. And that row number is actually called I cannot write here, so I can write maybe in here. So that row number is row NUM. So that is some kind of like a meta column. Okay. It's not really inside a table or a query, but every time the result will automatically have like a row number attached. Does it make sense? So when I run this, so let me run this one. Let me see, SoundX salesman. Okay, so you see that automatically have like a row number attached right here. Okay, row 1, row 2, row number 3, like that. So we are going to use that row number to as a special feature to do rundown sorts and rank sorts. Okay, so let me use the example, and then there's really not much we need to explain. So let me just create use example to explain how do we do rundown sorts and rank sorts. Okay, so here the question is asking you to find the first records in the employee table. Okay, so what are the first records in the employee table? So let's just say select star from EMP, and then first 5 records. So we are going to use their original orders row number. So we say where row number is less than first 5, right? So less than 6. Would that be enough? So that will be 1, 2, 3, 4, 5, right? So let's see that. So again, so you get a 5 employees from the original table. The first 5 rows only. Does it make sense? Yes or no? Pretty simple,
Yes.
right? Okay. So now we can use this feature to do actual meaningful search. So first one. Okay. Find the top 5 salary makers. You wonder, that might be very difficult, right? So remember to find the top 1 salary maker, what is the code? To find the top 1 salary maker, so highest salary maker, we do this, right? So employee name, and we have to use a tuple variable, right? Tuple variable, so a.e name, a.e name, and then a.salary from employee A, and then we have to make sure the A salary is matching the maximum salary for A's top 5 salary makers. So actually the salary, so we do not really need to use a tuple variable in this case. So salary must be the maximum salary for the entire company. So we can do that. So let's just say select max of cell from EMP. So that is top 1 salary maker, right? So I was thinking about each department. So this really does not have to do with any department. So that will give you the top 1 salary maker. Okay, so get that. Now let's say how can we extend that to say we want to find the top 2 salary makers? Can we? Can we extend that to find the second salary makers? Second highest salary makers? What do you think? Is it possible? Yes, it's possible. But then for this one, we probably have to wait until our next lecture on so-called recursive queries. But there's no simple extension of that, because this time you cannot find what is, so you cannot know what is a second max salary, right? Second max salary. So you know that. So this cannot be extended to find the top 5 salary makers. Okay, need the top 2 salary makers. Need the less to see the top 5. Okay, so how do we solve this problem? So this is just okay. Let's mark that as top 1 salary on is top 1. So now we are to top 5. So we have to find another way to do it. Okay. So what is other way to do it? So this is what we'll do. Okay. So first of all, let's say I want to let's create let's select everything. Okay. Select everything from EMP. Okay. For EMP, and then let's say order by salary, and then I will order them in which order? In descending order. Descending order. So that means top salary will be the highest salary will be the first, and then second highest, third highest, so on and so forth. Okay. So I will use this to get all the employees and sort their salaries, sort the result by salary. So the top, the highest salary will be in the top row, first row, and second highest will be second row, so on and so forth. So I can use this SQL statement as like a subquery to get a temporary result. And from that temporary result, I'm going to get the first 5 rows of this. Get the first 5 rows. Okay, so I'm going to put that into parentheses. Okay, and then I will say this. I'm going to get data from this. Okay, so now let's finish the first part. Select ename, salary. Okay, like that. Okay, and then from here, from this subquery. This subquery will give you all the result, all the employees, and that these employees are ranked by salaries, right? And then we just need to return the first 5 rows. So row number is less than 6. Okay, so this will be much smarter solution than this one, right? That make sense? So let's run that. Okay, so King, Ford, 2, 2, 2, 1 by 1. Okay. So if we're trying to use this approach to solve that problem, top one salary owner, then actually the question can be simplified just like this. Select ename. We do not need to use tuple variables. We can. Okay, just a ename and a.cell from. So what we do? So here. Okay, we cannot use because we are using subquery, so subquery to get that, so it's not longer tuple variables. Okay, so we'll just get that, and then here inside subquery, I will do select everything from EMP, and then I will order by cell, and also in descending order because we want to find the top 1 salary owner, right? And then we'll do well row number is less than row number is less than 2. So that will be just top 1, right? So this one and the previous one should give you the same result. So let me say I have an error somewhere, invalid identifier row number. I think I misspelled here. Okay. There we go. So we found the king, which is highest salary owner. So this approach is kind of like a more flexible, right? More flexible, allows you to find top 1, top 2, top 3, any number, any number in. Okay, but of course there's a cost, and then this time you basically have to create like a temporary table, and also sort that temporary table, and that the subquery actually takes a while to get. Okay, it's more time consuming to run this. Okay, than the first one. The first one is actually much easier, and the second one is much slower. Okay. All right, and so based on the same idea, we can do rundown sorts too. So let's say I want to find 2 rundown employees. Okay, so 2 rundown records, rundown employees. Okay, or top 2 rundown or 3 rundown or just 1 rundown does not matter. Okay, so let's just do 2. Okay, so what do we do? First of all, let's say we will do the same thing as just previous one. So what do we do is this time we'll order by not by a salary. Instead, we'll order by a rundown number. Okay? And then everything else will be same. So let's say select name, or maybe some other columns, and the from. Okay, so this from, I'm going to create a subquery. Okay, and then say where row number is less than 3. So that means we are searching for just first 2 rows. So now we need to construct the subquery, which will be searched from the main query. Okay, this subquery will create a result which is in the rundown order. Okay, so let's say select star from emp, and then this order by. So how do we get it rundown? How do we sort? How do we sort the results in a rundown order? So we'll be using something called what is it called? The rundown function. Okay, that's dbms. Okay, and then rundown. Okay, and then that value. Okay, so using this dbms, this is actually a package. This is a package, SQL package. So you're using that SQL function to generate rundown values, and after using that rundown values to sort the result. That's what it means. Okay, and after the sorting, because the original order is not randomized, so now you can just say get the first 2 rundown, the first 2 run. That would be rundown 2, right? The first rundown records, so 2 rundown records, because the order does not matter anymore. It's all random. So you can use the first 2 or second 2 or last 2, does not matter. Okay, so this is just whoever going to the first 2 will be selected. All right, now let's see the result, and then we found a tuner Smith, and let's do it again. And tuner Blake, see that every time should have different values. Adams Club. Okay, and then Smith. So you say that the record should be different, okay? Because the rundown number is generating different numbers every time. All right. So now let's say, what if I want to have some kind of not just the place? I can sort those employees by in terms of their salaries. First employee the first, second highest salary, or not in the second, something like that. And what if I also want to have like a rank associated with those? Okay, so I will use example to demonstrate that. So you can use a function called rank, and then the function will be able to say rank over certain things, certain certain column values or expressions, and then you can use that. Now, then you can generate a rank around that. So let me give you an example first. Okay, so here. All right, so we're trying to get employee commissions with ranks. Okay, so let's say we want to get select name. Okay, let's say maybe job and commission. Okay, and then I want also show the commission. For each commission, I also want to show rank. So you're using a function called the rank. Okay, function. And then you have to specify over which column. Okay, so I'm going to over the commission column. So you order by com. Okay, and then you can say I want to use descending order, DSC descending order. So order by commission. Okay, from that in descending order, you create a rank. So the highest will be the first rank, second highest, second rank. And for commission, you also have null values, right? So you can specify that. So all null values go to last. Okay, so last. So null values last. Okay, and then put that in the parentheses. So now you can just imagine that this rank will be generated from here, from this. Okay, nulls last. NULLS. Okay, nulls last. Okay. And so like we can also give a name, say this is rank. Okay, this is rank. And then we say from EMP. Okay, from EMP. And then we can also do where class, and then we can also do order by. So let's say we can order by commission again, commission, and then in descending order. And then I also can say last. Okay. So and that you see that all these employees, there's this commission rank, commission rank, commission rank, and then all the nodes will be the last, so they all have the same rank. Okay, so those employees does not have commissions. Okay, so this is how to use get rank. So you rank this function over, and then you specify how the rank will be generated. So I want to generate it based on commission and order by commission, and in which order. Okay. Okay, pretty simple, right? Okay. Now let's do. So this time I want to do a little bit more than that. I want to also in SQL statement show sub windows, or maybe just call it cursors. So I want to find the departments and the employees listed under each department. So tuple variables again. Okay, so what do I mean? I want to show all the departments, for example, department number, department name, and department location. And then under each department, I want to also show the employee information. Does it make sense? So employee ID, employee name, job, all that. Okay. So I want to get into like in one place. So let's get the main part first. So we want to show department number, department name, location. Okay. And then comma. And then also one for that each department, I want to show their employee information. Let's just put that into like a question mark first, okay? Question mark. All right, and then let's say from DEPT, right? From DEPT. Okay, so basically, essentially, we are trying to get all department information, but now this department has to have a matching employees. I want to show employees in here. So how do I do that? Okay, so first of all, you have to match. We have to match this department with the employees, right? So somehow, let's say I want to use maybe we can use tuple variable in here. Okay, from department from this. So for each department, this tuple variable will be varying from every department, and then for each department, I'm going to get those responding employees. Okay, and then let's just do a subquery. So the subquery in this case is not going to have one record, so it's going to be multiple records. So I'm going to call that is going to be like an entire record. So will be displayed as one in one area, one block area. That's called a cursor. Okay, so that cursor is going to show the select statement result. So select, let's say EMP number, email, okay, and then what else we need? Job title, and now say from EMP, okay, and then we have to make sure that this employee, this employee information to be displayed will be matching this department D, right? So we have to make sure that this EMP.DEPT number. So let's just use tuple variables again. So it's kind of a good practice to do that. So let's just say this is employee A, okay? And then we will say employee A's. For each employee, I have to make sure that A's department number, DEPT number, is equal to D.DEPT number. Something like that. Okay, so now let's try to make sure that all tuple variables are matching. So we look at each department. Okay, so for each department, I'm going to have a department number and also department name and the department location. Okay, and then for that department number, using that department number, I'm going to search for employees and I use another tuple variable A. Okay, so I'm going to put the department A, employee A here, and employee A here. So you see that this is just like a tuple variable we did last class, right? Does that make sense? Okay, and so for this cursor, we can also give a name. So let's just say this as employees, Okay, make sense? So department number, department name, location, that's the main query. Okay, main result. And then under each one, you have like a employees, list of employees. And this list of employees will be generated from this select statement. Okay, this select statement actually return multiple rows, right? So it's going to be like a multiple result. So I make that as a cursor. Okay, and then run it. So we get the result. However, it's not, this is a SQL developer does not give us the result showing the way we would see if I use SQL Plus. In the SQL Plus, we actually get like a sub window to show you that employees information. Okay, but it's there. So the information is displayed as, location, employees. I don't know. Probably it's difficult to present this as a table itself, as a sub table itself, because this SQL developer showing everything, showing result as one table, and then each table has like columns and cells. So basically, I think this is probably the best they can do. But if you use SQL Plus, which is actually a more common tool for doing SQL queries, but it's a little bit tedious to learn some kind of like editing features, comments. So starting from last year, I think I switched to SQL Plus, and before that we were using SQL Developer. Before that we were using SQL Plus. So for many years we were using SQL Plus. So anyway, so the result is there. Result, to give you some kind of sense like that, but it's not showing as small window, small table inside a table. Okay. All right, and I think this is about rank search and rundown search. Okay, let's take a break, 10 minutes break from here. We'll come back like 8:25, maybe 24, something. Okay. All right, let me stop, temporarily pause recording, resume. Okay. So it's called the recursive functions. So exactly what is this? What is this recursive function? It's a function, the function code inside the function calls the function itself. Okay, so this may be just a little bit, maybe a little bit abstract. Let me just give you an example here. Suppose I want to create a function, let's say f n, okay? And this n is trying to calculate factorial, like say 1 times 2 times 3, and then times n. Okay, suppose I want to create a function to do that. So what we could do instead, of course, we can use it. There are many ways to do that. Okay, so you can use a loop, to multiply all the numbers 1, 2, 3, all the way to n to that the multiplication, the result. So set the result equals to 1, then you can do that, right? Alternatively, we can use a recursive method to calculate that, to calculate fn. So what does it do is first, let's say if it's 1, n equals to 1, then this is easy. It's just 1, itself, right? So this part is easy. But then when we're trying to calculate fn, I will convert that into fn minus 1, and then that times n, time multiplied by n. Okay? So you see that when I try to program this function fn, I will call the function itself to calculate the factorial of n minus 1 first, and then use that result multiplied by n. Okay, if this is still abstract, let me give you just a very concrete example here. So I start with 1 equals to f1 equals to 1, right? So now let's say if I want to try to calculate f6, okay? So how do I do f6? And what I will do is I will convert that into f5 first, and then times 6. So get f5. Then when I try to get f5, I don't know how to calculate f5, right? So I convert that into f4 first. That times 5, and then times 6. Okay, again, I don't know how to calculate f4, so I will convert that into f3 times 4, and then times 5 times 6, right? And then f3 is still, I don't know how to do that, so I'm going to convert that into f2, and then times 3, then times 4, times 5, times 6. So this part will be just, so in every step, you call the function itself, and you multiply by the number. And finally, f2, I don't know how to calculate f2, so I will just do f2 convert into f1, then times 2, times 3, times 4, times 5, times 6. You get the idea? So now f1, that is already given to you. So I already know that f1 equals to 1. So this is a simple example to demonstrate how recursive function is doing. So basically the idea is that you're trying to do a function like fn, which might be complicated to do, okay? But then you reduce that to another one. You use the same function to do something else, to do a simpler one, and then use the simpler one, gradually reduce the simplicity to the level that eventually to the beginning part, the f1 equals to 1. Okay, so in this case, factorial is f1 equals 1. But of course, for some other functions, this initial part can be also obtained easily, and then you set that as anchor, and then you're going to, so when you program this fn, then you call the function itself to do fn minus 1. Okay, and then gradually reduce the complexity step by step, all the way, and then eventually get to the point that you can use the anchor initial condition to provide a result. Okay, so this is basically just called the recursive calls or recursive functions. Usually, when you create a function, the function can call other functions, right? But you cannot call it itself. But here, this type of functions will call it itself, and use the function which has not been even programmed to do something simpler job, and then gradually reduce the simplicity step by step to the level that is simple enough, and then you can stop. Okay, so basically recursive query is based on the same idea. So what is the idea here is that, so when we have some kind of very complicated job, but we can reduce that complexity step by step to the level that just, to some kind of basic step, which is easy to do. Okay, let me give you an example to begin with. That example, I think, is very, let me close that. Okay, so recursive code. So let's say, let me just follow this order here. Example 1. Okay. Okay. It's too long. Let me just split into multiple lines. Let's get rid of that. So the question is, ask you to list the employees in their hierarchical order of supervision. What does it mean? You want to list the president first, right? And the president will supervise the vice presidents. So then you list the vice presidents next. And then the vice president will supervise managers, right? So then you list the managers next. Okay? So then you just follow the order. So follow the chain of the orders to get all the employees in there in the order of the chain. So how do you tell that? So if you look at the employees table, select star from EMP, right? And you say that this employee has a chance, and the chain is same from this manager, this manager here, MGR column. Okay. So for example, Jones is supervised by whom? 7839. 7839 is Kim, right? So you list John before, list Kim before Jones. Does that make sense? So this is so we will get all the employees list in that particular order. Okay. Does it make sense? So first, apparently we can find those employees that have no supervisors. So that will be done by simple job, like I say, ENP number and E name. Okay. E name, and we can also list a manager. Okay, manager, and from EMP where the manager is now, right? So this will give you all the top employees, the employees who will be listed in top. So which actually just Kim. So Kim does not have any supervisor, any supervisors. So he's president, right? So we wish that we could do the next query based on this one, right? From this one, and I want to find out the employee that supervised by this employee. Okay, and then after that we get more results, right? We get this, so we basically get so there's Kim and then somebody else, maybe Jones. Okay, and after get a Jones, and then we wish to use the Jones. Use the Jones again. Use the new record to sort for next level employees who who will be supervised by those employees. But the employees we already found. For example, we found a Kim and a Jones, and then we want to find the employees supervised by Jones. Does it make sense? So do you say that so somehow this has like a nature of recursive, right? So you get the first result and then use that result to search for next level result, and use that new result to search for next level result step by step. Does it make sense? Okay, so this is what we're going to do. So how do we create this kind of recursive queries? So we will use so basically, we are going to use the wait clause. This is new, okay? Does not start with select, but it's actually select statement, okay? And the wait, and then you specify that this wait will construct some kind of like a temporary table. You can give a name for the temporary table, let's say T, okay? And the T will have, say, for example, a bunch of columns. So I will say each table that has two columns. One is employee ID, okay? Another one is maybe like a manager, or maybe employee name, okay, E name, and then manager, MGR, or maybe just create another name. So we don't have to use exactly the same name as columns. We can just rename those columns, okay? Instead of using employee number, can use EID, and then just use this one, maybe say employee, okay, employee, and then manager, something like that, okay? So we're gonna create a table recursively using this wait clause. And then inside inside. So let me put that inside here. So basically, curly brackets here. So inside the curly brackets, you're going to have two blocks. The first block is called anchor block. So basically, so you know, it's just like a most complex job will be reduced all the way to the initial step. This is a beginning step. Okay. So that I was just trying to make that as the first initial block. Okay. And then the second block will be, say, you use union and all, and then this will go to the second block. So second block, you are going to use information. You're going to use in the second block. You're going to reference to the table you are constructing step by step, right? So you're going to use another query, and then in that query you can reference to this table, reference the table you already constructed. So let's come back to, let me just do that. Okay. So okay. So now we'll come back to the second block. Let's do the first block first. Okay. So the first block, I'm going to get those people who the top level person who does not have managers. So I make that as employee name, as employee ID, and then e-name as employee. So trying to match the name of the columns we are using here. So we are using the 3 column names, right? So now we are trying to do just matching those. Okay, matching those. Select employee member as employee ID, e-name as employee, and manager. And this manager is going to be, let's just say, as a manager, MGR as a manager. Okay, and then from EMP table, and then where manager is now. So basically, there's no semicolon here. So this is one subquery. Okay, so you can use put a parenthesis around that. Okay. So the one subquery, and then we're going to union all that. Union. Okay. So then we're going to have second block. The second block, I will be getting the same, pretty much same information like employee number, employee name, and then employee, and also manager. But then we have to reference to the table itself, the table we are constructing itself. Okay, so let's just try to finish the first part here. So I'm going to say select that. So let's do the first part, second part first. From, let's say EMP, okay, from EMP, and then let's just say employee A maybe, and then we also reference the table T. Okay, we have to reference to table T here. So we are using those tables using for EMP table and also the table we are constructing. Okay, the relationship between these two tables is clear. So A dot, so we have to make sure that the employee we are looking for next, whose manager, MGR, is equal to the table we are constructing. Okay, the top, after I find a president, I want to use president's employee number. So that would be EID. Okay, so I have to make sure that this manager, the employee I'm looking for, his or her manager number is the employee ID of the table I'm gradually constructing. So you can just imagine. First, you're getting presidents, right? So you're just trying to find employees. Case finding employees. His manager number is same as the president's EID. How to get a president's EID? So that's recursive table we are constructing. Okay, and now we can just get going back to the main thing what we want to do. So we want to say this A dot ENP number as EID. Okay, and A dot ename as manager. Oh, this is as employee. Sorry, as employee. So you have to imagine that. So all this, when you use a union, then I said that the column names must matching between subqueries. Okay, so EID, the first one, and then the second one is employee. Third is manager. So we'll do that here, comma, and then we'll do A dot MGR as manager. Okay, and now we have to make sure that this table we are we are using this tuple variable here, A. And then the table T is the one we are constructing. So that's recursive, okay? And from this current table, the table we are constructing, we're trying to get the employee IDs and use the employee IDs to find the employees that have a matching manager number. Okay, and I think that's it. So now just imagine that this with class will be able to construct all those employees in a hierarchical order. So including the hierarchical table will have employee ID, employee name, and also this manager. I don't know why this is something here. Manager has, what is this? Okay, I think let me try to finish that first. Okay, so after we have this the table temporarily constructed, then we can just write a regular statement to find the result. Okay, so we'll do select EID, employee, and manager from T, the table T. Okay, so basically we constructed the temporary table, and now we are running the final statement to get the result from that. Okay, and so the difficult part here is just understand how to construct this table, how to construct this recursively. So the idea here is I get the presidents first, and then I use the president's employee ID to find employees who are supervised by president. So that's how I use join the second table, join the table T here. When I joined, I found that employee ID, president's employee ID matching this employee number. And after I have this new records added, and now I will be able to use the new records to find out the employees who are supervised by the employees already inside the table. Something like that. Okay. So let me say, I think I have some kind of issue here. Let me see, what is this? The curly brackets. Let me run that. Let me see whether I can get a result. Give me the error message. So it says missing keyword. Missing keyword. Okay, missing keyword S. S. Okay, sorry for that. Okay, so with the T as this one, still have the same missing keyword action. Let me see. It still have the kind of arrow here. So missing left parenthesis. Do you see anything left parenthesis missing? There is something wrong inside. So let me see. T and I call it the parenthesis here. The left parenthesis and the employee ID, employee, and the manager as select employee. So let me see what you get rid of this parenthesis. I don't really I don't need it. It's just trying to see the logic clear, make logic clear. And then that is not the issue here. And I think it's something else. Did I miss something? Oh, let me see. This code was running successfully. Okay. And then what else here? This one is successful. Sometimes it's just because the code before that it was having problem, and then it impact the code you're writing. So I don't see anything wrong here. Did I miss anything here? With T, EID, let me see, this comma, employee. I don't know whether this manager has like a keyword, has like a highlighted, whether that makes any problem. Should not, manager is keyword. Should not be keyword. So let me just change it to man. Let's see whether that makes any difference. Probably not. Man. and men and men. Still not, it's not because of that.
So,
So-
Professor, we have to use curly brackets or simple round brackets.
Which one?
For with, after, as, we have used curly brackets, right?
Yeah, this call it, yeah. That should be, that is parenthesis, is it? Oh, that's parenthesis, sorry for that. Thank you for that. That's parenthesis, it's not a curly brackets. That's right, so that is wrong. Okay, so that was the reason. So let me try to put this manager back. Curly brackets. Manager. And manager. Okay. Okay, so hopefully I fix everything. Now, yeah, that was, thank you for that. So this, mistype that. Okay. Calling parentheses. So you say that the employee, King and Jones, and then Blake is also supervised by King, right? And that's also by King. And now Ford. Ford is supervised by 7566. 7566 is Jones. See that? And then Adams is the bottom. Okay, that? Okay. So if you combine this with combine this query with the query we did before on how to do rank search. So if I want to find out employees who are supervised, who is at the bottom of the chain or the command chain, who is at the bottom of the command chain, then what you should do? So you should be able to find those, right? So after you have this chain created, then you can just search for records using row number. Somehow you have to just like invert the order. Okay. Okay, so this probably will be, you can just imagine that we will get into this stage. This SQL is getting very, very challenging or complex. But good news is that this will be the last SQL lesson. Okay, let's try to use this same technique to practice this recursive query one more time. This time I will use a different question. The question, let's see whether you can think of another solution besides using this one. So sometimes we have different solutions, okay? Different solution strategy. But this one, the only thing I can think of is using this recursive queries. Unless you can tell me there's another way to do it. So here the question is, you want to find the years in which the company did not hire any employees. Find the years in which the company did not hire any employees. Okay, so you probably, okay, so you're probably trying to do this. Okay, so this is incorrect. Okay, trying to say select future, okay, and then hire date, and then say y, okay, from BMP, and then say group by future. Okay, and then say heaven count number of employees equal to 0. Can somebody tell me why this is incorrect? Anybody? Why this is incorrect? Sounds right, right? Sounds right. So trying to find a year in which the number of employees hired is 0. But this is, we have the same, we did the same kind of question before. We find a department that has no employees. And that is actually, we have the same problem here. So here, if we find a year that inside the employee table, that higher year, if that higher year is already in the employee table, then that year must have at least 1 employee. That makes sense? It will not be 0 employee. Okay, so now how do we solve this problem? So now they say I want a year does not have any employees, so this year number can be what? Can be any year, right? So we're talking about a year, let's say 1800, 1801, 1802. Of course, those, there's a possibility that there are some employees hired in those days. But based on the table we have, most employees hired in like 1981, 80, 81, 82, 83, 84. Okay, so the question is, which years I should show? Which years I should show that has no employees? Okay, so of course we cannot start with 1700 and all the way to 2020, right? That would be too much, right? So one scenario would be I want to try and say all the numbers starting from the earliest date, maybe like 1980, starting from 1980 and then 1981, then 1982, and all the way to 2020. And then we'll say that say those years, which years have employees, which years does not have employees. Okay, or we can just say I want to say between the minimum hire date and minimum hire year and earliest hire year and the latest hire year. So for example, the earliest was 1980, the latest was 1985, and then I only check those years, 80, 81, 82, 83, 84, 85, and then I say which year does not have employees, right? So the question is, how do we generate those years? How do we generate those years? Okay, so that we can use those years to check to see whether the employee has, whether this year have employees. So the difficult part for this question is, how do we generate the years? Okay, and you cannot actually say this year's starting from 1700 all the way to 20. That would be too much, right? Too many. So let's just say I want to start with the earliest year, all the way to current, to for example, to 2020. And then we check each year to see whether this year, we have employees. So if we know all the years, then actually it's probably will be easy to find out, to check, the years that, to check years we have employees, hired employees, right? And then we could use a minus or use some kind of not in, something like that, right? Okay, so now the question is, how do we generate these years? So this is the first part is easy. I can find the earliest year, okay? Earliest year by using just like the minimum hire date, okay? So the first part is easy. So I will do, okay, let's just divide the Congo. Okay, first, okay, what is the earliest year? Okay, earliest hire year. Okay, so that one should be simple. Just say select two child. Okay, and then use the minimum hire date. Minimum hire date, and then convert to year. A minimum hire year first. Minimum hire date. Okay, and then from the minimum hire date, I convert to year number. Okay, so using two chart, and then let's say this is year, right? It's year, and then we say from EMP. So that will give us the earliest hire year. Earliest hire year, right? Okay, and then after we have earliest hire year, then we use the method of just simply add 1 each time to this all this one, step by step, right? So second year will be, for example, if this one gave you like a 1980, then the second year you want to generate is 1981. And then after that, we're going to generate use the existing one to add 1 again. So that would be 1982, 1983. So every time I'm going to use this existing result, add 1 to generate the next year. Does it make sense? So to do that, I'm going to use recursive. So let's do that. Okay, so with, okay, let's use also T. So this time I will just get a year number only. Okay, and then parentheses. And then inside the parentheses, I'm going to have 2 blocks. Okay, so union, all, and then we have a second block. Okay, so like something. Let me just do that first. Okay, create the first block first. Okay, so the first block is clear, and then union all, and then let's do the second block. Okay, so the first block will get the all this year number from the employee table. So based using the minimum hire date and then convert that to year number. Okay, and then the next one I'm going to just use the year number, the one we just get year plus 1 as year again, as a year. Okay, and then from which table? From T, from the table you are constructing, you're currently constructing from T. Okay, and then I will say, well, we have to make sure that the year number we are trying to source is less than the current year number. Okay, so year is less than. How do we get a current year number? So that would be 2 char, and then say hire date. No, not hire date, sys date. Sys date. Okay, and then let's just say y. Okay, so that will give you the current year number from sys date. Okay, so this recursive query. The recursive query is just use whatever you already have, the year number you already have, and use that plus 1. Just make sure that the year number you generated is going to be less than the current year. Okay, and then this will generate all the years, right? That will give you all the years. So I think I have some kind of a problem somewhere again. So this time I use parentheses with T S. Okay, S. Okay, with T year as that. Okay. And after we have this the list of years. So basically T will have list of years and all years starting from all these years up to 2020. And then we can use the query, the main query to source this year number to see, to source this table to see whether this each year has employees or not. Okay, so we'll do select year from T, from this T, the T you're constructing. Okay, and then we're trying to say that in that year, the year not in what? We can just do find the year or the list of year numbers from use the subquery list of year numbers from EMP table. Okay. Okay, so that subquery will get a list of year numbers. So as long as the year you're looking for from T is not in that list, then that's what we're looking for. So select 2 char. Okay, hire date. Okay, and then y. Okay, from EMP. Right? So this will give you all the year numbers. All the year numbers. So as long as the year you're, from this generated years starting from minimum all the way to today, as long as the year is for each year you check to see whether the year is not in this list or not. If it's not in this list, that means those years we have no employees. Does it make sense? Okay, if it's in, then basically those years we have employees. Okay, then we do not need to use subquery like this. Do not need to use this recursive query to find the years. So here we just need to find the years which does not have employees. All right, now let's run that, and hopefully this is correct. No, it's not correct. Let me see what's wrong. Must have the same data type as corresponding expressions. Let me see whether we have that. Data type has data type problem. Okay, so expression must have the same data type as corresponding expression. So what happened here is, let me see, this two char is actually is a character. So let's just, probably that's because of that. We need to change it to numbers. Okay, let's do that. So have to make all the whole thing convert, put in type to number. Okay, to number. So that will convert to numerical numbers for the chars. Close here. So that will make sure there's a number, okay, from EMP. And then here, then this part is fine. So year plus 1, that would be numerical numbers. And then year less than that, hopefully this one should be okay. But just be safe, let's also do conversion to number. Then convert the text into numbers. Okay, so then this will give you make comparisons of year number from the T to the current year number, okay, which will give you 2020. And then select year from T where you're not in this. So let's do another conversion to number. I said that the Oracle sometimes is pretty tolerant of not using to number for text. Okay, so now let's run it again, and then we get all these years. Okay, so 2016, 18, blah blah blah. Okay, and then we may just let's just order the number, order by year. Okay. From that, and let's say order by year. Okay. So starting from 83, 84, 85, 86, no, all the way to today. Those are years the company has not hired any employees. Okay, so here we are looking for starting from the oldest and then to today. And what if you want to search for the employees between the oldest and the latest? For example, you have you may have like just years in between that is missing. Okay, let's say so you have employees hired in 1980, and then 81 you do not have employees, and then the latest like 85, and then I just want to list the years in between those. So if that is the case, then this query can be changed a little bit. Okay, so let me just do. So let's change this one. Change this one. This is years up to today. Okay. And then let's do another one. Say years up between and the oldest and the latest higher. Yeah. Okay. So if that's the case, we still use the same like a recursive query. So let's say T. This T is just a name. You can use any other name. So let's say column name is year, and S. Okay. Parentheses. Okay. Now let's construct two blocks. The first initial block is like anchor block. That is easy. I just want to find the oldest one. So select. Then say to number, okay, and then to child, okay, and then the date we want to convert is minimum higher date, okay. From the minimum higher date, I get a year number, and then parentheses, so that will give you your number in text, and then convert again in a number, and then say this year from EMP. Okay, so this is anchor block, and then we'll do union all. Now let's do the recursive block. So recursive block will be referred to the existing block using just we have to reference to this table T. So let's say select year plus 1 as year. Okay, from T, from the table we are constructing. Okay, and then this time I will to make sure that the year number which we are looking for is less than the maximum, the latest higher year. So it has to be less than. So let's put a question mark here. So we need to put like your subquery to find out what is the maximum higher year, right? So that's what the subquery is going to do. And then after that, we're going to do same thing as before. So select year from T, well, year not in, again, subquery to find out the list of years. Okay, and then some column here. So now let's try to do the subqueries here. So first subquery is trying to find maximum higher year. Okay, so we'll do select to number, and then to char. Okay, so what the higher date we want to try to find is a max. Okay, max higher date. And from the max higher date, I will convert into year number, y. Okay. And then from that text, I will convert into numbers. Okay. And then from EMP, right? You see that? So just imagine you get my maximum higher date, and then from that maximum higher date, you just convert into the year number using toChar. Step by step, okay? And then from the chart, so they basically just like a single quote around 1984, something like that. And then you to number, you get rid of this single quote in the front EMP. So that will give you all the employees, all the years, less than or equal to, maybe less than should be fine, because we're looking for employees. Does not have like the years does not have employees. Okay, but if you add equal to, it should be okay too, because the next one, the next subquery, the main query is going to find the years which does not have employees. So find the years that is not listed in this. Okay, so maximum year will be filtered out. Okay, so now let's do the main subquery here. So here is basically the same thing. We're trying to find out the list of years that the employee already have, that the employee table has employees hired. So we'll do select to number, then to char, okay, and then hire date, and then convert that to year number. Okay, and then this is to char, and then this is to number. Okay, from EMP. From EMP. There we go. So that part is the same as this one. Okay. And if we want to order, then we can do that. We can just say order by year number. By year. So this time, instead of listing all the years from August to today, this will list all the years in between the maximum and the minimum. Okay. So let's see whether we find anything here. Invalid identifier, to char. Let's see, to char here. Okay. Start again. All right, so we found 1983, 84, 85, 86, and 88. So those years does not have in place. Okay. I don't know which year was latest, probably 1989. Okay. Good. So this is how we can use recursive queries. So the second question appears a little bit more complex just because we use two number, two child multiple times, no max, all that. So basic idea is, so if you split the whole thing into simple ones, the first you find the first year number. And then just make that, put that into a t-table. So t-table will be having like, for example, 1980, right? And then based on the t-table, you're going to generate the next one, next year number. So that's why you do year plus 1, okay? And then you have to make sure that the year you generated is going to be less than the latest higher year. Okay, in the previous one, just make sure that is less than 2020, the current year number. Okay, and then make sure that you're calling that recursively. So after you get it, for example, 1981, 82, then you're going to construct 83, 84 recursively. Until when do you stop? Until this, make sure that this year is this year number is, there's no more added. So when you say year less than equal to that, then you will stop. Okay, so this just continuously adding more years to this t-table. And from that t-table, now you can just just write another query to find out for each year. Just make sure that your number is not in this year, in this list of higher years that you can find from EMP table. Okay, hopefully this is clear, and if not, you can. I trying to construct more questions, but then I realized that you already have 20 questions in the list. So unless I get rid of some other questions, I guess I will. I was just trying to come up with a few more questions, put into like a warm-up questions for next lecture, and then we are done with SQL. Okay, and then next week. I think next week is going to be the week before Thanksgiving, only week before Thanksgiving. Let me double check. So next week will be 18th, I think. So then Thanksgiving break, I think we will not have class, right? 25th will not have class. So, and then after that, we are going to have 2 more weeks, I believe. So we will have 3 weeks covering no SQL database. Am I right? So when is the finals week? Let me check schedule here. Syllabus. So let's see. The final week. Let's see, December. No, I'm sorry for that. December 6th is the last day. Okay. We have only 2 weeks left, actually. We have only 2 weeks, and then week of December 9th is the finals week. We're gonna do final exam. Okay, so originally I scheduled to have 3 weeks on non-SQL. What happened? 1, 2, 3. Oh, I see. We did a one week review. That was no, the review week was already in there. Let's see. SQL. Oh, 4 weeks SQL. No, 3 weeks. 4 weeks. So we did 4 weeks SQL. So instead of 3 weeks as originally scheduled. Okay, so we did 1 extra week SQL. So let me see, why is that? Oh, I see. So we did simple queries, and then we did multiple query and group functions in the second week. And then third week we did subqueries, and the last week we did this. So we actually the first 2 weeks stuff was actually covered in 3 weeks instead of 2 weeks. So we lost 1 week actually. So for some reason, that is not expected, not anticipated. I don't know what I did wrong. So we did not. I thought it was the speed was normal. I did not not make it slow. So anyway, we have. It turns out that we have only 2 weeks to cover NoSQL stuff. So let me think of what we should do. Probably we just get rid of XML data structure. Just go directly to MongoDB. Okay, 2 weeks on MongoDB. All right. Let me see whether anybody have questions at this point. Let me stop recording.
The homework is due Friday evening.